Hello everyone, here we are going to discuss different shapes of equipotential surfaces. In the previous video we have already discussed what is equipotential surface. The surface where at every point the potential is same, we call that surface as the equipotential surface. Now here we are going to discuss different shapes of equipotential surface. First of all, we are going to discuss equipotential surfaces for uniform electric field. Uniform electric field means the value of electric field E is constant. We have a formula E is equal to dV by dr, where if E is constant, it means dV by dr is a constant quantity, which means dV is directly proportional to dr because dr comes here, so it becomes directly proportional. It means dr here represents the distance between the equipotential surfaces. Here is an example of equipotential surfaces drawn for an uniform electric field. The uniform electric field is shown by parallel lines which are equidistant from each other, acting in the same direction, positive x-axis. Now this area, everywhere the electric field is same E. Now there are three equipotential surfaces which are shown here. The first surface, every point of which has the same potential V1. Second surface, every point has a potential V2, and the third equipotential surface, every point has a potential V3. Now here we have discussed that dV is proportional to dr. dV means the potential difference between the two plates, the two equipotential surfaces, V2 minus V1, is directly proportional to the distance between them. It means if the difference between V2 and V1 is same as V3 and V2, then the distance between this and this two will be exactly the same. The meaning is the potential difference between two equipotential surface, if it is same between V2 and V1 and between V3 and V2, then the distance between V2 and V1 and the equipotential surfaces V3 and V2 will be same. So these are the equipotential surfaces which are equidistant from each other and which represents an uniform electric field. I think this is clear to you. Now let us move to another type of equipotential surface, and that equipotential surface is due to a point charge. Now let us consider a point charge here. Suppose this is a positively charged body, a positive charge is kept here. Now we know E is equal to minus of dV by dr. That means dr is inversely proportional to E, that is the electric field. So if this is the case, it means for this positive charge, the electric field, as we move away, the electric field decreases. That means as we move away, the value of dr will increase, that is the distance between the equipotential surface will increase. You can see here the distance between first and the second equipotential surface is less, but as we move away from the charge, the distance between the third and the second equipotential surface is greater than the distance between second and the first. That means as we move away, the electric field decreases, but dr, that is the distance between the equipotential surface, increases. Further, you need to understand these are the equipotential surface for the charge which is shown here, and there can be infinite number of such equipotential surface. You need to understand that these all surfaces, they are spherical in shape, and since the charge is at the center, the points at the surface will be equidistant from this charge Q. So naturally the value of electric field 1 by 4 pi epsilon naught Q by R square. Since the value of R will be same, so every point in an in the sphere here will have equal potential. So all of them are, all the spheres which are drawn here are equipotential surface, but their distance are not same. As we move away, the distance between the equipotential surfaces goes on increasing. Now let us discuss a next type of surfaces for 2-point charges. Okay, now let us consider two positive charge. Both of them have same polarity, but their charges are also same. So we know that electric lines of force, we have discussed earlier, the electric lines of force, these are the shape of the electric lines of force. In the property of equipotential surface, we have discussed that the equipotential surface will be such that the electric lines will be perpendicular to the surface. Now look at the shape here. You need to understand and remember the shape. The shape is made in such a way for the equipotential surface so that at every point the electric lines which are cutting these surface are at 90 degree. Okay, so you need to understand that for these positive charges, the shape of the equipotential surface will be as shown here in the shape of oval. So you need to be very clear with this. Now second option, we take one to be the positive, another to be the negative charge, equal and opposite polarity. Now electric lines of force, we have drawn it. These are the electric lines of force. Now you see the equipotential surface. The equipotential surface here will not be in oval shape. They are spherical, but as we move away from both the charges, they will be increasing the distance between themselves. So here they are spherical, and in the first case, when the charges are of same polarity, here it is positive. If both of them are negative also, then also the shape remains the same for the equipotential surface. The direction of electric lines of force will change then. So this is very important and for the CBSE board exam also, and you need to remember this. For equal polarity charges, the shape will be in the form of oval, whereas when the polarities are different, one positive and another negative, then these will be spherical in shape. I hope this is very clear to you, all the points which are discussed here. So if there is any doubt, you can post the doubts, right? And you give me the feedback, because the feedbacks are very, very important for me, because on the basis of that, the videos which are going to come in future will depend. Thank you.